We're looking at how to do propositional logic, and we're considering logical connectives and truth values of compound sentences in this video. To get started, let's think about how you symbolize the various connectives that are used. And a conjunction can be symbolized with a dot, sometimes the ampersand, which we're familiar with, meaning and sometimes the wedge or an inverted V, something like that. And these all mean and. I prefer the ampersand, it's straightforward. An arrow is the conditional representative, so it is between the if-then conditional sentences. So when you see the arrow, you know you have a conditional. The wedge is for a disjunction. It means either or, and this is an inclusive disjunction when we're using it in logic. The tilde in front of something means not. This is a negation. So in front of a P, it means not P. So if the P is just the sentence, my phone is in my backpack, you put the tilde in front of the P, and that just means the phone is not in the backpack. And finally, the double arrow is representative for if and only if. These are biconditionals, and these are sentences that are composed of conditionals going in both directions. Truth tables are tables that chart all possible truth values for any given designated sentence, and so these can be very useful for assessing validity. To complete a truth table, you have to know the conditions under which conjunctions, disjunctions, conditionals, biconditionals, of course, negations. You have to know the conditions under which all of these things are true and the conditions under which these things are false. And so overall, then, the goal of truth tables is to allow you to check for validity of a propositional argument by seeing if there's any way that the premises may all be true and yet the conclusion false. And if there is such a way that the premises could be true and the conclusion false, then the argument form is invalid. If not, the argument is a valid deductive argument. Just a word about parentheses. When you use parentheses, these are just as important as in math. In math, there are actually assumed rules about when there aren't parentheses, but just consider this sentence here, 5 plus 6 times 7. If you group it in one way, you get 77, right? But if you group it in another way, you get 47. So it depends on the grouping, what you are meaning there. And this is similar with propositional logic. So if you just run connectives together with the sentence letters, like this, P, N, Q, or R, that is an ambiguous sentence. That sentence could be read as P and Q or R, or it could be read as P and Q or R. But those have different meanings, just like the sentence 5 plus 6 plus times 7 has different meanings. And they could have different truth values because of that. So when we have complex sentences, you need to make sure that you're using proper truth parentheses in order to illustrate these differences in what you might mean in order to disambiguate the sentence. So consider the above when P is false, Q is true, and R is true. Now in that case, we have P and false, P being false, Q being true. So the first conjunct to the disjunct of the first sentence is true. R is true, so the first sentence is true. But in the other sentence, we have P being false and Q or R, where that conjunct is true, but we have a false conjunct with another conjunct that's true, but that sentence as a whole is false because one of the conjuncts is false. We'll work on these at the end of the video to make sure we're very clear on this. But before we go on to multiple kinds of sentences, I do want to talk about De Morgan's laws. De Morgan's laws are rules for converting between conjunctions and disjunctions with negations. So there are 4 different laws on how this works. Not the case that P and Q, well, that's the same as saying not P or not Q. So if it's easier to understand one way than the other, you can just swap those. These are laws that allow for logically equivalent sentences to be expressed in different ways. So let's consider with P being I am sleeping and Q being I'm awake. So it's not the case that I'm sleeping and awake. Well, that would be equivalent to saying I'm not sleeping or I'm not awake, right? So let's look at another one. If you have, it's not the case that P or Q, well, that's going to be equivalent with not P and not Q. So these are the 2 most common De Morgan's laws. So in the first case, let's say P is I'm a cat and Q is I'm a supervillain. So it's not the case that I'm a cat or I'm a supervillain, which means I'm not a cat and I'm not a supervillain. So those are logically equivalent sentences. Now, these are a little bit more complex. You certainly wouldn't want to go from the left to the right with this De Morgan's laws, but this would be very helpful. If you're given the sentence on the right, you can convert it to the one on the left. So P and Q is equivalent to, it's not the case that not P or not Q. So if we have P as I'm hungry and Q is I'm sitting, well, we have P and Q, I'm hungry and I'm sitting. That's equivalent to, it's not the case that I'm not hungry or I'm not sitting, right? That allows you to go from that more complex sentence, the second one, to a very simple sentence, the first one. And we can do the same with a disjunction. P or Q is equivalent to, it's not the case that not P and not Q. Again, you most likely in a scenario where you would want to convert the second sentence to the first for a much similar form. So let's have P be I'm speaking and Q be I am sleeping. Well, it's not the case that I'm not speaking and I'm not sleeping. That's equivalent to either I am speaking or I am sleeping. So these are helpful laws that allow you to go back and forth. You have to be very careful with these, though. You have to follow the precise laws there that are given here when you're going back and forth between conjunctions and disjunctions when there are negations involved. Also remember that the double negation, so not the case that not P, that is equivalent to P. Let's talk about compound sentences and go through the rules for compound sentences and talk through some examples. Truth values for compound sentences simply build up from those of the component sentences. And then you just use the rule of the connective. So you may have to use the rule a few times when you are putting together sentences with parentheses. So let's, for the following set of sentences, assume that P is true, Q is false, and R is true. Now here, we're not even going to say what P, Q, and R represent. We can still tell whether these compound sentences are true or false, just given this information that P is true, Q is false, and R is true. And so what I encourage you, I'm going to talk through each sentence that is here. And I just encourage you, though, first to think through them to make sure that you understand what's going on, and pause it here. Then on the next slide, I'm going to talk that through. Okay, so let's talk these through. Again, we're assuming that P is true, Q is false, and R is true. Well, what's the truth value of this conditional sentence? It's a conditional sentence. The first antecedent is P or Q, and we have P being true, so that's going to make that disjunction true. So we have a true antecedent. R is true. Well, we have a true consequent, so the first sentence as a whole is true. Consider this conditional sentence. The antecedent is a simple sentence P. The consequent is Q and R. In the case where Q is false and R is true, that consequent is false. Here we have a true antecedent, false consequent, so the sentence as a whole with a conditional is false under those circumstances. For this one, we have a conjunction. We have Q and R or P. Well, let's think about the R or P. If R is true and P is true, the R or P is true, but Q is false. And so this conjunction as a whole is going to be false because one of its components is false, right? If you're affirming two things, you're saying they're both true. If one of them's false, then your whole assertion is false. Let's consider this one, either Q or if R then Q. Here, if R then Q, we have a true sentence for the antecedent, false for the consequent. So that second disjunct is false. Well, Q is false. So that means this sentence is false. A biconditional here with P. Biconditionals are true when both sides of the conditional sentences match in truth value. If they don't match, the biconditional is false. So here on the left, we have P being true. So the question is the right side true? In this case, since it's a disjunction where R is true, that makes the disjunction true. So we have P is true, and the second part of the conditional is true, biconditional, I should say. So they match in truth value. So number 5 is true. Number 6 is also a biconditional. Here we have Q is false on the one side, P and R, those are true. On the second side, the conjunct is true. They don't match in truth value, so number 6 is false. Number 7, we have another conditional. Here our consequent is P and Q. Well, when we're conjoining a true sentence with a false sentence, we have a sentence that is false, but Q is false, the antecedent is false, and when you have a false antecedent, a conditional sentence is always true. So 7 is true. And then finally, a conjunction with R, which is true, and P or Q, the disjunction, and these are inclusive, of course, and if P is true, then the disjunction is true. So we have the second conjunct being true, the first conjunct is true, so that is a true sentence for number 8. From here, you can now, once you know the rules on building up these more compound sentences, you can go to my video on truth tables that is linked here.